Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 5D. Myself Sirali Gaur and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information Communications Technology for Sustainable Development, ICT4SD 2026, Goa, India. The 11th edition of this conference is being organized in a hybrid mode. The physical event is being held today on 9th of July 2026 in Goa, India, and the virtual event is being held through Zoom from 9th to 11th July 2026. I hope you enjoyed the knowledgeable and interactive sessions through the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentations and 2 minutes for question and answers. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any update, please feel free to write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session today. Dr. Varsha Tanaji Lokare. Dr. Varsha is an assistant professor at Rajaram Bapu Institute of Technology, Maharashtra, India, with 18 years of teaching experience. Her research areas include brain computer interface, artificial intelligence, machine learning, deep learning, networking, and iOS app development. She is actively she's actively involved in teaching, research, and academic innovation in emerging computing technologies. We welcome you to the session, ma'am. I would request you to kindly share a few words with us today.
Hello.
Hello, yes,
Am I,
ma'am.
am I audible?
Yes, ma'am.
Okay. Thank you for a brief introduction. So today we have around 10 presentations. So I think all have already joined. So thank you so much for providing me opportunity as a session chair for this. All the best to all participants. Be stick to a time. Okay. All the best. Thank you.
Thank you so much, ma'am. Now, with that, I would like to start with the papers. Our first paper today, one second. Our first paper today is by Sanket Lokare with the paper title A Large Language Model for Code Generation Using LORA, a Deep Learning Based Approach. You may start your presentation, please.
Hello? Hello?
Yes.
Yeah, I don't know what happened. I lost his contact. So,
Sir, we are beginning with our first presentation right now.
yeah. Is somebody presenting?
Not yet, sir.
So, can I go on? Can I present?
Uh,
We will be following the sequence that is mentioned on the conference website, and the host will call out your name when it's time for the presentation.
Sorry, I didn't get you.
We will call out the name when it's time for the presentation. Sirali Sanket isn't here in the session, I guess, so we can go ahead with the next presenter.
All right. So, because I don't know, before I lost connectivity again, I don't know. Did we go on break?
No, ma'am, we are just starting with the session right now, and your name will be called soon. We are going in a sequence. Okay, we have Sneha Agarwal with the paper title AI based multinational road damage detection and classification using YOLO V8 deep learning architecture. Dear presenter, are you there in the meeting?
Sneha is present, but she's not responding. There might be some audio issues. All right, we will move to the next present.
Okay, our next presenter is Akanksha Katuria with the paper title An Integrated Real-Time VFX Pipeline Using Advanced Image Processing in Hybrid Film Environments.
Good afternoon, respected concerns. Am I audible?
Yes.
I'll share this.
Yeah.
It is shared.
Yes, it's shared.
Good afternoon, everyone. So my presentation title is An Integrated Real-Time VFX Pipeline Using Advanced Image Processing in Hybrid Film Environment. So my co-authors are Dr. Samram and Dr. Prashant Kamal. We are from the Amity University, Rajasthan, and Dr. Samram is from the Amity University, Dubai. So now starting the presentation, I would like to tell you about what actually the VFX is and about the part of it. VFX is basically the visual effects used in the animation field. Animation field, by combining it, is divided into the three parts: pre-production, production, and the post-production. And VFX comes into the post-production part. That is the basically when we go for the editing purpose, last taking out the final output. Now coming back to on the topic, now how the VFX has impacted the our film production field, animation field, and what is the difference between the traditional VFX and the real-time compositing VFX field. So now bridging the gap between the imagination and reality. The earlier the VFX field was like going into the production. In pre-production, we used to write out the concept, prepare about the things, and in the production we do the shooting or make the animation, and in post-production we make the editing, VFX, and color grading and taking out the final output. Now bridging the gap between both the things, and now difference is in the next slides over there. So the hybrid filmmaking combines traditional cinematography style with the real digital compositing, and enabling how we can remove the chroma at the time of the live action, and it can do the color correction and depth mapping, so we can save out the time. In the traditional VFX time, we used to apply the VFX in the post-production part. Means after doing the shooting, it goes to the other artist in the post-production. Then it starts applying the color grading, putting out the effects over there, doing the sound design, audio mixing, all those parts. Then if some error comes, then again the reshoot process need to be done. The methodology used for this paper is totally the experimental based. We use the experimental design to evaluate the real-time VFX integration with chroma keying in a control studio, recorded high-resolution footage on a particular green screen, and performing a professional camera technique over there to perform a task. Then we performed a real-time GPU-based compositing to integrate VFX on a set to instant the visual feedback. Then we compare the real-time output with the traditional workflow, and then we related both the methods and check the accuracy, image quality, and the lighting technique over there. So the research objective was to develop and evaluate the real-time VFX impact in the production pipeline in removing the chroma, then to assess the quality of it at the time of the live compositing itself rather than going on the traditional VFX process, and to analyze how effective the GPU-based real-time compositing system is, and to identify the real technical challenges and the limitations that come particularly on a set at a live action particular part. So now the procedure which was over there, the live capture over there, we use the setup, studio setup design, capturing over there, and at the same time using the GPU compositing system to remove the chroma at the time of live shooting only, and to see what actually the effects is. We have experimented in real, and I do have the footage screenshot of that showing how it already affected the compositing system. So this is the basically the setup design over there. Subject is over there, means a corrector over there. Then we have the light setup, light rings, and the Canon. We use the Canon 750D on the tripod, and directly it was connected with the GPU with the chroma key, and the external monitor was going on. So this was the setup. For this setup, we need the high quality of the lights over there. If any light effect is there, it will not give a good quality of the output. We need a proper soundproof room. We need a good quality outputs for the light, and the proper setup over there to take out this experiment. So this was the experiment we did in the Amity University Rajasthan studio itself. So she's sitting over there, the chroma screen we can see, and we were just all the lights are over there, and we were sitting there. I said that, and we were connected this chroma screen with the GPU based system, and at the time of shooting itself, we had removed the chroma, and we experimented this thing. So the real composite provide a near final preview. It allows directors to accurately frame demonstrate a tree, and we put the banyan tree over there. And but the thing is, the lights was proper over there, so that output was able to come out over there. If light would not be properly over there, the light effects and the chroma, we cannot take out the final output. Now, why it is different from the traditional output? In traditional, first we make the story, then production, then the next process go for the post production, where do we do the things. But here, if we will do at the time of the live action, and any occur in any hindrance come at the time of shooting, it can be corrected at particularly that time. But in the traditional, it was like that every whole shoot is completed, then whole clip is sent for the editing purpose, then effects are put. If anything is come, then we have to reshoot again the whole. It is the time consuming plus the money wasted over there. But here it happens at the live shooting. You are doing immediately shooting, and immediately the removal of the chroma is experimented over there. So the problem with the traditional VFX flow, delayed feedbacks for their continuity of the risk and like extended timeline. So director cannot visualize a final composition at a particular dead time. Lighting and spatial mismatch was over there because of the external and internal light sources, and linear post-production workflow and the cost of the production schedules were extended because the shoot, if any other error occurs, so we have to reshoot it over there. So basically, these are the parameters which shows the difference. So in visualization, it is not over there available in the real time. Lighting is after post processing. It is immediately, particularly on a set. Production time is longer post. Now it reduces over there. And here the workflow type is linear, and that is parallel, means interactive side by side goals. So risk of reshoot is of course higher in traditional, means earlier style. If we go for it, it is the lowest type for that. So these are the technical processions for faster turnarounds and creative controls which we opt for it, particularly if we opt for this particular lifestyle over there. Now, if we say the AI-driven generative VFX, if come over there in the means the future scope, the real-time pipelines paves the way for the AI-based prompting techniques. Then the prompting can done on the set. Future hybrid film environment will leverage AI to instantly pre-visualize particularly scene, and to particularly work on the VFX at a more faster speed with the AI prompting, and it can tell the error more accurately, more fastly, so we can go further for that. So thank you. That was all from my side.
Thank you so much for that presentation. Does anybody have any questions?
Yes, Akanksha.
Yes, ma'am.
You have integrated VFX technology over here.
Yes, ma'am.
So previously, whatever traditional methodology that you have compared, and
Yes, ma'am.
Along with that VFX integration. So my question is regarding how you measure accuracy of this.
Ma'am, for accuracy, we measured it with showing on a particular field. Like we took the same clip and we took it in the post-production process. Everything was same over there, but the thing is, it is about the time, mainly time utilization. In the real time, it is like I do not need to do the reshoot. If some error comes at the time of the shooting, then I have to reshoot again all the things. But in real time, director can pre-visualize and can see what actually the output is going to come, and they can see directly on the live stream. So it saves the time, it saves the money, and it we doesn't need to do the reshoot process and do going through the production phase again.
Right, right. So, have you referred any base paper for this?
Sorry, ma'am.
Any base paper, any research paper you have referred?
No, ma'am. It is
For
totally
this
experimental
implementation?
based.
Okay, so there is no any such type of work previously done by anyone. That is the case.
Ma'am, in Hollywood, it is, we have tried it, but in Bollywood, it is not there till now.
Okay, okay, good.
And they had experimented only, ma'am, but still now it is not transmitted anywhere. Like whole film is not made till now.
Okay, okay, good.
Thank you, ma'am.
Thank you so much for that presentation. Now we have Pranav Sriram with the paper title AQI Aware Route Planning in Urban Networks, a systematic review of health driven navigation, multi objective optimization, and real time data integration. Dear presenter, you may please start your presentation.
Ma'am, yeah. I hope my presentation is visible.
Yes, it's visible.
Okay, good afternoon, everyone. Good afternoon, dear panel members. Today I'm going to be present my a review paper on the topic of AQI awareness routing planning in urban network, which is based on the systematic review of health-driven navigations and multi-objective optimizations and real-time data integrations. So I'm the research scholar from Department of Computer Engineering from doing my PhD in Dr. Subhash University, Junagadh. Okay, so during these presentations, I'm going to be present today's the introductions, my research objectives, literature reviews on health impacts and algorithmic foundations. One of the findings which I have identified during my literature review, which is multi-objective optimizations of Pareto friends, empirical results and research gaps and the future works, along with the conclusions. Coming to my introductions, you know that 21st century is the biggest problem for AQI. So the AQI is drastically degrading the air quality of in this world. So recent study is identified by WHO. There are 7 million premature deaths annually is happening. This was the recent WHO reports was mentioned. And again, India, if you look at that, India is the sixth most populated country in this world. So basically, this report says that it consistently breaching that CPCB and WHO safety limit. CPCB is one of the Central Pollution Control Board, which defines some framework on based on that AQI. So if you look at that major, who is the major impacting on these AQIs? So every day, you know that you and me, every day we are traveling for our daily professionals work. So most urban professionals are spending their significant times of portions of their time for traveling. So they are traveling through congested roads, industry zones, constructions, corridors area, with some of the highest level populations exposures are there. And at present, there is no such a system is available to give some guidelines based on that AQI. So this air pollution exposure can seriously cause with the health issues in the children's adults, like they have facing the issues with their lungs functioning, repository infections, headache, asthma, and hair losses. So again, I have already mentioned that if you look at that, there no active health driven rerouting navigation application is available. Yes, few applications are available, but it is based on that AQI level. It is not for reroute of the safest path of the user. So there are major critical research gaps are there. In the existing modern navigation systems, if you look at that Google Maps and Waze, which only optimize the times and distance, it is not entirely ignoring the toxic exposures of the same. So this is the one of the major issue which we have things. So there are a lot of opportunities are there. We need to be work on this area. So during my research, these are the few research objectives which I have defined during my review paper. The first thing is I just need to be identify the novel method to the reduce the pollution exposure. So basically it minimize the individual exposure to harmful the pollen during the day travel through the intelligence route. So again, most of the important thing which we need to be consider, I have identified in this research survey, this to be identify what are the health impact will be happening on this AQI. So we have categorized into the short-term health impact and the long-term health impact. So bridge gap, critical gaps are there. So if we have some novel systems which we can connect the environmental monitor system with the practical real world navigation systems, so definitely it will be reduce the health impact on daily commuters over there. So during my research review basically focus on three major areas. The first is the air quality index. Second thing, how these air quality index are impacting on the human health. And the third is what are the alternatives way we can provide a safest route to the user, that is the routing algorithms and navigation systems. Coming back to the my first, which is AQI based and health related impact. CP, that is a Central Pollution Control Board, has already defined some framework. They have defined some guidelines. They have categorized this AQI into the 6 categories. Based on these categories, again define the threshold values, that is the AQI range. If you see that if AQI value from 0 to 50, what will be the health impact and what are the major precautions we have to take? They have been defined in their framework. So if AQI is 0 to 15, there is minimal impacting on the human health. There is no precautionary action is required. Like that, they have defined the multiple categories. The one is the satisfactory, moderately polluted, poor, very poor, and the serve. If you see that severe, in the severe, if AQI lies between the 400 to 500, it's majorly affect on human health, even in the healthy people, seriously risk to the diseased persons. So emergency protocol was again defined in that CPCB framework. So it is to basically they are advising to avoid the outdoor activities on there. Coming back to the table 2, which I have identified during my research, what will be the impacting on the human health? So it was categorized into the two part. One is the short term and what is the long term. When we are considering the AQI majorly consists of these 6 to 7 parameters. So one is your nitrogen oxide, carbon monoxide, sulfur dioxide, carbon dioxide, PM, that is particular matters, and other gases and other particles are there. But majorly this initial 4 parameters is crucial and very it is impacting on the human health. If nitrogen value increases in the AQI, so what will be the short term and long term will happen? So short term is inflations in airways of the highest level. So what will be the long term effect? Is decreases the lung function and increases the respiratory risks. The same like that carbon dioxide, it's a fatigue, headache, imprisoned impact will be visible in the human health. So again, the long-term impact will be coma, brain damage, death of the high cumulative exposures. So sulfur is again creating a big impact on that human health. It will be impact on the chest, throat, nasal irritations, coughing. And long-term impact is the persistence coughing, wheezing, shortness of the breath. Carbon dioxide, again CO2, drowsiness, dizziness, shortness of the breath, and in the long term impact it evaluated blood pressures, coma, death. In some cases extremely death will be also possible. Major impacting on the lungs, which is called as a PM 2.5 or PM 10, which actually drastically changing in the environmental parameters. So it is impacting on human health, repository irritations, asthma, and long term impact is the lung cancers and cardiovascular disease also be identified few of the patients. So coming back to the health, which just these two figures are showing that the figure 1 illustrates 6 AQI health categories with their associated impact descriptives. So this is a simple or not relation between pollen concentration and the health risk, underscore the critical importance of the real world AQI monitoring. So again, if serious health hazards, even it will be impact on the healthiest people. So satisfactory level, so minor breathing issues, moderate level breathing comfortables, people's having a lungs and disease, these people can be more impacted on if they are traveling through moderate air polluted. Breathing discomfortables if it is lies between the AQI in 200 to 300 range. So these are the, so again each air pollutant have been categorized into the low risk range. So that is from lies between the 0 to 200. During my literature survey, I have gone through the multiple papers, which is based on that their approaches, which algorithms they have using, what are their contributions and the limitations. The first author has demonstrated, studied the number of different research paper based on the urban health, and what he has identified the air pollution as the major urban health hazard, which is impacting on the human health. Basically, they have only showcasing the health related issues, but they have not going to demonstrated how will be reduce the health impact on that. So no routing models and real-time implementation was there. Second author has again demonstrated AQI-based smart routing, so which are basically use the Dijestra's algorithm to finding the healthiest route. Again, it is was the limitation limited to the statistical data, lot of lacks of real-time validations and all. One of the interesting thing which I found, that is green route planners, which is based on the AQI based navigation systems. Again, they have done some modified this is RAS algorithms and A-star algorithms. They have provided some personalized and predictive healthcare routings. Based on what are the basic limitation of these studies, they have only have the prototype, is not tested the large scale environment. Like that, Google is also be the part of this. They are providing the AQI based data for that user to identify the quality of ears, but data is not sufficient to be demonstrated. One of the interesting paper which we have found, which is used to apply for the navigation system, which is called as the transportation network comparison. They have done some algorithmic comparison, that is Dirichlet versus ant colony optimization, that is ACO, which they have demonstrated the both algorithm performance, and Dirichlet's performance is better than that ACO. They have tested only the small logistic network. So based on this, we have to be understood how the routing algorithms can be used to AQ and navigation systems. So during this literature review, most popular algorithms have identified they have some limitations over there. So if we can modify this algorithm to use the navigation system, definitely we can find out some good result to identify the safest. But the first is again most popular algorithm is a this is RAS algorithms. It deterministic graph-based algorithm. Basically, it is work on the single objectives. It is optimal and efficient solutions for the in navigation systems. Again, major limitation is it cannot be handle the multiple conflict, because when you are working on the navigation system, you need to be identify multiple route for the safest path. So basically, it is not suitable for multi-objective shortest path. So again, the second algorithm, A-star algorithm basically used for the Google mapping. Again, is the heuristic based algorithm, single objective, faster than the Dijestra's, but it is not fully single objective. Its multiple objective are more complex and modified. Limited support for that multi-objective shortest path. One of the interesting, which is more relevant algorithm, which is the Pareto optimizations, which is work on the multi-objective optimization systems. Basically, it is work on the two parameter. One is that AQI and the distance. So again, limitation is the it is computationally expensive. The large set of solution is required. So it is highly suitable for navigation systems. Third algorithm, that is ant colony optimization, meta heuristic based algorithms, again supported by multi-objective path. It is good for the dynamic and complex environment, because we know that our environmental parameter are drastically changed. So it can be more suitable for this. Again, major limitation of this algorithm, it's a slow concurrence. This is suitable, but it is slower. Most suitable, most interesting algorithm which is identified most suitable for this navigation system, which is called as a k-short path. So it is a deterministic numeration based algorithm supported by multi objective shortest path. Basically, they have generates the top k alternative path, multiple path it is going to be generated, where user can be decided which path he has to be selected. It provides the multiple route options, and a re-optimization process is also been there. Again, it's a highly suitable for navigation systems. Coming to the my next, so one of the algorithm which is Pareto.
Presenter.
Yes, ma'am.
You have crossed your 9-minute mark.
Yes, ma'am. Yeah, just
Continue your
earlier.
presentation.
So this is one of the most suitable algorithm which provide you the multiple paths. So again, I have identified two empirical evaluation system. One author has been demonstrated one model, which is Pareto based optimal balancing model, which can be using this method. We can reduce the PM 2.5 20 to 30% or NO2 up to the 25%. So coming to the identifying the research gap, there are a number of research gap I have identified during my literature's review. One is the static and the real data. All data have tested in the statical data. There is no real time data was being tested. Again, disconnected with the health. Some of they have shown the AQI based navigations, but they have completely ignored how was the health impacting on this air pollutant. So these are the few limitations which we have identified, just like a limited statical data prototype to the deployment gap. There is all or simulator based, no production ready applications are been there. Future ready directions. Again, there are a lot of future scopes are there. Statistical validations. We need to be compare the different root algorithms, validate the using the statistical analysis. Predictive, of course, predictive AQI based, AI based. So we have to be use the AI ML to predict the future AQI level. This is one of the things we need to be explored over there. So personalized health awareness route. We have to be provide some recommendation route based on the user health conditions. So there has been the larger scope of these applications. Again, recently government have initiated IoT based smart cities integrations. This will be again, if we can integrate the real time data with the applications, definitely we can find out the better result over there. Conclusions. So again, the urban pollutions, increasing the health awareness, creating the strong AQI with smart navigation systems. Already CPCB has defined the framework. We can use this framework. Using this framework, we can implement one of the suitable algorithm. Definitely, we can achieve the one of the best result. Again, work on that PM 2.5, NO2, CO2. These are significant impact on the health. So that we have to be consider. Not we are not going to be considered generalized AQI, but we have to be considered. These are the few parameters are there. So this is all about my side. These are the reference. Thank you. If
Thank
you have
you so
anyone,
much. Does anyone have any questions?
Yes, sir.
yes, ma'am.
This is just a review, like
Yes, ma'am.
whatever implementation done till date, right?
Yes, ma'am.
As I heard, you are doing your PhD right now.
Yes, ma'am.
So, have you think of like whether any publicly available data set is there for such type of implementations?
Yes, ma'am. Madam, basically the previously which I have studied, all those author have demonstrated with the data sets. The question is that this application is completely based on the real-time AQI based systems, right?
Right.
So predefined data set will produce the different result than live-based AQI-based data sets.
Definitely,
So
but for training purpose, you must have some historical data, right?
yes, ma'am.
Yeah.
Yeah. So for this purpose, historical data, the few websites are available where we can download it the past 1 year, 2 years data.
Okay.
So this data is available. If you see that, I think Aki is the one of the application is available. Even they are providing the API based the connections to the systems. So we
Okay.
can download it their data and we can test it on that the data.
Okay. That will be a great thing. Suppose, as you said, you are going to consider multi-objective, like
Yes, ma'am.
shortest path plus this uh, air quality.
Healthiest route. Right.
So that will be definitely great thing if you implement it, and even you can go for patent also.
Yes, ma'am. Yeah. Thank you, ma'am. Thank you so much.
Good. Good.
Thank you.
Thank you so much for that presentation. Now we have Kashish Goyal with the paper title Empirical Evaluation of Vision Language Representations for Fine-Grained Fruit Quality Classification. Dear presenter, are you there in the meeting?
Yes, ma'am, I'm there in the meeting. I'm just sharing my screen.
Okay.
Sorry, meanwhile, should I leave this meeting, ma'am?
You can stay till the closing remarks.
Okay, yeah. Thank you.
Thank you.
Is it visible to everyone?
Yes.
Okay. So good afternoon, everyone. I'm Kashish Goel, and I'm assistant professor at Thapar Institute of Engineering and Technology. Today, I'm going to present our work on evaluating vision language models. Particularly, we have worked upon CLIP for fine-grained food quality classification. And in this, we have solved a simple problem that a simple model that is generally trained using images and text, is it actually a good trained model to solve a particular problem? Then this is based upon this, we have done this work. So food quality inspection depends upon subtle visual cues, small bruises, discoloration, minor defects. Traditional deep learning model handles this but needs huge large label set and struggles to generalize on new foods and environments. Vision language models like CLIP links images and text in a shared space in a shared embedding so that we can classify using natural language prompts without retraining. But it's unclear whether CLIP's general semantic understanding actually transfers to this kind of fine-grained task. This is what we have performed here. This is some of the prior work that people have done in this, particularly not exactly in this field, but to the related field. Then we have some research gaps, that how reliable is the zero shot learning on subtle quality differences? Is it able to identify that apple is a defective or it's fresh apple based upon that? How much prompt wording matters? Like long, I have in this we have worked upon short versus descriptive prompts, and how much adaptation is generally necessary for particular use. So this is our major contribution in the work. We have showed that short performance is unstable on subtle cues, showing lightweight adoption is enough to fix that without even touching the pre-trained model. A systematic look at how prompt complexity affects the zero shot predictions. And then we have used this dataset. It is publicly available dataset for three fruits: apple, oranges, and lemon. And it's classified into two classes: good and bad quality. In this, we have performed two stages. One is zero shot inference. In this, we have compared the images against the text prompts in a CLIP shared embedding space. We tested for a short prompt, for a medium prompt, and a long prompt. Then same, we have fine-tuned the model for lightweight fine-tuning. Like basically, we have freezed the initial visual encoder part and trained just a small linear classifier for based upon the images that we have given, and for two different comparisons, for a zero shot and a lightweight fine-tuned results for three different prompt styles, for a good, for a medium, for a long, and a short descriptive. This is the basic visualization diagram. In this left, we have developed how the compared the cosine similarity, and in the next one we have, this is the complete layout of the work that we have performed. First of all, we have collected the raw data that was available, then data pre-processing and the feature extraction, that is the thing that we do every time. Then the classification for good quality and for testing data. Then we have the end-to-end fine-tuning and the zero-shot results for both of the labels, for all three different labels, short, long, and medium labels, then the model training and the model evaluation. So results shows it is highly inconsistent, that zero shot results are not very impressive because it was not actually trained for that. So it was struggling on the subtle defects. After fine tuning on a small linear layer, accuracy jumped over 94% for every fruit. Shorter prompts are more stable in zero shot. Longer prompts are often added noise. And these are the accuracy parameters for F1 and accuracy and the F1 values and the accuracy parameters for different classes, for short, medium, long for apple, for zero shot, as well as for fine tuning, similarly for orange, and similarly for the lemon. These charts also make the same point, that the gap and variability before fine tuning versus the flat high line after and write tenfold cross validation confirmed it is generalized over data splits. And coming to the conclusion that pre-trained visual models are not immediately ready for fine-grained tasks like this, but they even not does not need an expensive retraining. A small adaptation is enough. So in future, we'll be testing the generalization on other datasets and dig into a more robustness analysis. That's it. These are some few references that we have used. Thank you.
Thank you so much. Does anyone have any questions?
So, you just focus on three types of fruits. That is the case.
Yes, ma'am. In this case, we have worked for 3 fruits.
Okay. So that data set is available with publicly available, and that
Yes,
you have
ma'am.
used.
That is the FruitNet dataset, publicly available,
Okay.
image data, and the shop prompts that we have given, that I have given from, we have developed our own prompts for 3 different lengths, for a shorter prompt, shorter length, medium length, and a descriptive prompt. And then compared the results using this zero shot learning and the fine-tuned results, fine-tuned model.
Okay. So that prompts you have generated by your own. That is your novelty.
Yes, ma'am.
Okay. Okay. So what are your observations? Like three separate types of prompts you have generated, right? Short, medium, and
Yes, ma'am.
descriptive. So, from this, what are your research findings?
Ma'am, like shorter prompts were more stable in a zero shot case, but after fine tuning, because we have given model is fine tuned, so it is able to identify the subtle cues, even the small bruises on the defects of the fruits. So in that those cases, larger prompts were more effective, descriptive prompts, because it was getting more detailed analysis of the fruit.
Okay. In future, you can make it more generalized for all types of fruits,
Yes, ma'am.
vegetables.
Yes,
Yeah,
ma'am.
and
Definitely.
that you can able to add. Good.
Okay. Thank you.
Thank you so much for that presentation. And now we have Badula Sivasai Harshavardhan with the paper title Heart Disease Prediction Using Stacking Ensemble, Learning with Random Forest, XGBoost, and Support Vector Machine. Dear presenter, are you there in the meeting? Okay, moving forward, we have Amit M. Goel with the paper title Post-Quantum Cryptography in Defense Systems, a study of quantum computing architectures and security challenges.
Sure, ma'am.
Uh,
Can I share the screen now?
yes, you may start your presentation.
All right. Just a minute. Is the audio and visual as okay?
Yes, sir.
Okay. Good afternoon to all. Myself, Amit Goel, working as an assistant professor in Marwari University, and I'll be happy to present my paper today in the 11th International Conference on ICT for Sustainable Development. So my paper ID is 1096, and the title is Post-Quantum Cryptography in Defense System. That is the study of quantum computing architecture and various security challenges. So these are the key points which I have covered here. Let us go one by one with each and every points to this presentation. Comes to the very first part, that is the abstract. Here in the abstract, in this research particularly, the investigation has been done on the different quantum architectures which impacts the security of the defense communication system. So then after we have explored the post-quantum cryptography as a practical solution for protecting the sensitive military information, right, to prevent the quantum attacks, and then a various discussion about the global initiatives such as NIST, that is National Institute of Standard and Technology, and how they are working to safeguard the critical military system and ensure the long-term cybersecurity in the era of quantum. The research objectives. Here in this research objective, the primary objective of this research is to understand how the rapid evolution of the quantum computing could impact on the security model in the defense system particularly. First, we have done the analysis of different quantum computing architectures to able to understand the capabilities and how closely they are becoming practical for large scale applications. Yeah. Using the PQS, which are the existing system, and in addition to that, this research explores the practical implementation strategies, which include the hybrid cryptography, which combines the classical and PQS algorithm, as well as the hardware acceleration using FPGA based. Now, these are the quantum computing threats which has been covered. As you can see, the various algorithms of quantum, Shor's algorithm, Groover's algorithm, and HNDL algorithm. So mostly the first major threat comes from the Shor's algorithm, that this particular algorithm can efficiently solve integral logarithm problems, which forms the foundation of RSA, right? So in practical terms, once a large scale quantum computer base, the system becomes, so this widely used the public key cryptography system could be broken on a very short time. So this makes them unsuitable for protecting long-term military communication for a longer term. So because of this disadvantage, then after we have done the algorithm on the Groover's algorithm, that Groover's algorithm, it does not completely break the symmetric encryption such as AEC. But since the military information often needs to remain confidential for longer time, so this creates a significant long-term security risk whenever we are going to implement this Groover's algorithm. So this is the Groover's algorithm, and then the last one, HNDL. This will collect the longer encryption military data becomes vulnerable once the cryptographical quantum computers are available. So whenever we are going to adopt this PQC, at that time this agile system will quickly protect the data for the long duration. Right? So these are the evolutions The very first architecture is the architecture, this one, superconducting qubits, right? So in this, which is currently most mature and widely adopted technology, this one. So the companies such as IBM and Google uses the superconducting circuits that operate the extremely low temperatures. This system becomes perform the quantum operation in nanoseconds, right? So making them the fastest among the all existing architectures. The second one is trapped ion. In this approach, the electrically charged atoms called ions are trapped and controlled using the lasers. So in this way, it makes the system slower with the gate operation in microseconds. The next one is the comparison among all. Let me give you the summary quickly. The superconducting quantum computers is currently have the highest number of qubits. That means the with more than 1100 qubits available in as per the data available in the last year. So they also provide extremely fast gate operations measured in nanoseconds, making the system ideal for executing the quantum algorithms quickly. Then trapped ion although have the fewer qubits and slower gate operations measured, that can also be measured in microseconds. Yes, the superconducting is measured in a nanosecond. This one is measured in the microsecond. Then after neutral atom, it is the technology where it provides a good balance between performance and scalability. So these are the parameters. The gate speed is very moderate, but scalability is high. So it represents the promising direction for building a fault tolerance computing system. Overall, we can say that not a single architecture is quite perfect to implement the quantum system in the defense sector. So this, let's see the further how the security challenges are. Yes. So in security, the most critical challenge is to manage the data from the attacker's perspective. So to maintain the data secure for the longer term, because the conversion on the telephonic can be exceed for a few time. So to secure the data for a longer term, then the next challenge is the bandwidth. Bandwidth can be a problem. As a result, we required a higher bandwidth in some of the areas. So this become a challenge. Then power and computation limits. Many military devices like a radio and drones and some of the devices are integrated with the IoT based chip as well. So they are having some limited amount of batteries. So that is the way the limitation arise here as well. Then legacy defense platform. So in legacy defense platform, the systems such as fighter, aircraft, naval vessels, and military communication infrastructure often remain operational for 30 to 50 years. So that can be embedded and securely and cannot be easily upgraded. So making that consideration, this security challenges are there. Post quantum technique, PQC technique.
Dear presenter,
Yes, ma'am.
so sorry to interrupt, but you have crossed the 9-minute mark. Please conclude your presentation.
Okay. Uh, yes, so these are the PQC technique, lattice-based cryptography, hash-based signature, code-based. Each and everyone is using the different algorithm and having their own limitations. Let's go to the next part. In implementation, the efficient implementation to secure the network, that is the PQC, and that also can be by considering the hardware acceleration, which improves the performance, and the post-quantum cryptography. While this some channels and few algorithms need to be implemented and tested into the real world together, so that to make the system efficient for deployment of quantum safe cryptography in the defense system. Yes, so the future scope is to implement this quantum based system to prevent the our highly secured data of defense from the attack. So that's why we have to implement the QKD as well as the 6G communication protocols with the cyber security perspective to prevent the data from the attackers. Yes, thank you. Thank you. Few references, and this is the overall summary for this.
Thank you so much. Does anyone have any questions?
Yes, sir. Can you able to tell me the basic difference between cryptography and this post-quantum cryptography?
Yes, ma'am. In cryptography, we do have limited security, and in this PQC, we do have a cryptographic algorithm only, but that is designed to remain the secure against the attacker from both ways, like in the way of
How
classical computer and future quantum as well.
how we can able to get that more security? That is the question.
Using PQS and using PQS system only, ma'am.
Okay. So you have just taken a review of all the
Comparison.
things, yeah.
Yeah. Yes, ma'am.
Yet you have not tried for any implementation.
Exactly, ma'am. Yes, ma'am.
Okay. If you go for that, then that you must be in position, right? So what is the exact difference? Because implementation, no need to
Yes.
go for direct defense applications. Implement
Mhm.
small modules and try to
Mhm.
identify like how exactly these algorithms are working to
Yes.
provide
And you know, ma'am, I will thought of to try the data with the drone in the campus itself. So see how longer the communication will take place, and how the attacker are able to attack it, and that is the thing that I'll
even you
do
can
in
combine
future. Yes, ma'am.
multi objective things instead of only security, focusing on security, other
Okay.
parameters like bandwidth and other secure communication, multiple objectives you can think of. That will be great thing.
Okay. Okay. Sure.
Good,
Sure,
good.
ma'am. Thank you. Thank you for your input. Thank you.
Thank you so much for that presentation. And now for our next presentation, we have Eze C with the paper title.
Okay, thank you so much. I'm here.
Okay,
I would like to share my PowerPoint. I hope I know what to do. So,
yes.
Yeah. Should I send it to you? No? Or what do I do now?
You can
Share.
present your screen.
Okay, let me look at share. Okay. You say let me see. How do I get it?
There
When
will
I'm saying oh no, is sharing somebody? No. Stop. I got the way. How do I get to share it? Or I just present and people will be hearing me.
there is a share option on the bottom. You can just click that and choose which tab you want to share, or you can share your whole screen as well.
Sorry, let me get it first.
You have a share option on the bottom.
I've not seen the share button. Is it? I see the share.
Yeah, you can click on that.
But how do I get to my work?
There will be three options: Chrome tab, window, and entire screen.
Oh, because it's just showing me something else. I don't know. Share. Okay. Okay, it has come. Thank you so much. All right. So, it has come and it went away when as soon as I say it has come. Okay. All right. So here it is. Good afternoon, everyone. In Nigeria, it's good morning, but I'm the afternoon in India. So I'm Chika Eze. I'm presenting quality software and experience engineering education and gender equality for sustainable development. My co-presenters are Emmanuel Berjago and Uju Okeke Ozodike. So what is this paper all about? Are you seeing my sharing? I hope so. I don't know.
Yes, we can see the screen.
Okay, all right then. So what we are presenting is based on the fact, the background is based on the fact that the digital world has become a new norm. And it's nearly controlling every aspect of human life, social, educational, economic, institutional, every single thing that we can think of. Therefore, it has become important then that quality software and experience engineering education is vital for everyone, everyone, that is the ideal, to participate in engaging in the digital world. But there is always a persistent gender gap. This inequality that limits women to access science, technology, engineering, and mathematics, which across the globe we call them STEM. And so what is the problem? The problem is that as long as women continue to be limited, they cannot inclusively participate in software engineering. And this persistent gap probably impacts or has implication for quality education and gender equity. Quality education, SDG 4, and gender SDG 5. Hence, this paper addresses women marginalization in software engineering education through three interlocking dimensions: structural, cultural, and educational. So, the specific problem that this paper addressed is women underrepresentation in software engineering education and career development. Also, the prevalent software systems that are frequently designed without adequate consideration of diverse users, which include women too, and then fragmented framework. Educational institutions here lack coherent framework linking quality education, gender, and sustainable outcomes as interrelated. So we developed, or we were looking at using an integrative approach framework, whereby we are looking at what are the curriculum qualities. They should be technical rigor, ethics, sustainability, and human-centered design, and then experience pedagogy, project-based learning, so that they can learn on hands, and then gender-responsive support, There should be mentorship, inclusive policy, and a supportive learning climate. And of course, sustainable outcome, equity, innovation, etc. And so our research method is a qualitative meta-synthesis that tries to review empirical literature published between 2018 to 2025 in international database. And our aim is to synthesize existing scholarly research on quality software, engineering education, experience engineering education, gender equality, and collective contribution they make to sustainable development. And looking at the findings, for want of time, because 10 minutes we were told, so looking at the findings, there are 6 dominant themes that emerged. And these themes are in terms of conceptualization of quality software. Many of the publications that we looked at have this also as an undertone. Then emergence and role of experience engineering, then pedagogical processes in software and experience engineering education. And number 4, gender equality in engineering and the experience education. And then intersection between education quality, educational quality, gender equality, and sustainability, an outcome of also inclusive software engineering. But our focus would be on what is the gap in the reviewed literature. And so there are 3 gaps that we identified. And one of them is studied in isolation. What are we saying here? Oftentimes, quality education, software engineering, experience engineering, and gender are studied as if they are not connected. I mean, the presentation that previous research have, there is always a dissonance between some of the things, all these items or keywords. And then, of course, there is also the missing long-term development. There is limited empirical research explicitly linking experience engineering with long-term sustainability development. Of course, probably maybe that is not where they are going. And then there is also a geographic gap in the sense that developing nations are not much represented. And I don't even know, I think I would like to think that Nigeria is a developing nation, even though we are the giant of Africa. So in summary, the findings reveal that quality software and experience engineering education are essential foundations for sustainable development. And experiential pedagogy mediates the relationship between education inputs and the output. Of course, gender equality enhances both educational and quality sustainability. There also, integrated interdisciplinary approach remains unexplorable and need to be attended to. So based on this finding, we are recommending saying a conceptual framework linking curriculum quality, pedagogical, institutional support, and sustainable outcome is proposed. And of gender equality should be integrated into software engineering as to allow many more women who have the capacity and ability to participate actively in software engineering as a means of achieving the full societal benefit and sustaining the SDG goal 4 and 5. It is hoped that this will positively inform policy implementation, particularly in Nigeria and elsewhere. And then what contribution is our study doing? It has theoretical and practical. In terms of theory, we are hoping that it has extend experience engineering discourse into the domain of gender and sustainability. And also practically to offer policies and educational recommendations aligned with sustainable development. Together, this contribution would advance the creation of knowledge at the intersection of engineering experiencing and the quality and sustainability. Hence, there are some limitations, and the limitations for this study is we solely used secondary data. And of course, we also base it on recency. I mean, the publications between 2018 and 2025. And also, we focus on higher education. So probably these are limitations that all can be handled. And how can it be handled? So we are saying, moving forward, future research should expand to use a mixed method research if possible, and then explore context-specific implementation, particularly in underrepresented regions and developing economy, to understand how cultural, institutional, and then resource factors shape the relationship between engineering education, gender equality, and sustainable development. Also, there are also emerging frontiers that interferes or impacts on research, like the use of AI, artificial intelligence, is also something that is emerging, and we know how much it is trying to or threatening to overtake the world. So maybe future research should also take that into consideration, and all other issues that around computer and all the gadgets that are being used, and how gender interacts with social disability and ethnicity to develop a nuisance and the equitable education. So that's all. Thank you for listening. Your contributions, clarifications, and questions are welcome. Thank you.
Thank you so much. Do we have any questions?
Ma'am, so this my first question is regarding this survey globally you have taken, or this is country specific?
Sorry, please come again.
Whether this survey, whatever you have done regarding uh, gender inequality, so that survey is based upon specific country, or globally, worldwide you have considered?
Well, it's not based on specific country, it's global. But
Oh,
what we observe, the findings reveal, is that the literature that are available on net do not have much with developing countries or developing economy. So that's why we are saying the onus probably falls on us. I'm coming from Africa, I'm Nigerian. Can I and my cohorts of researchers do more to explore how it is or what it is and
yeah.
publish it?
Yeah. So actually, my concern is, if you have surveyed it globally, then country-wise some observations must be there. Or if you want to focus on your country only, then inside your country again, state-wise statistics must be there. So that will be helpful, like if particular country, particular state is facing such issues, then we can able to provide some recommendations to improve that inequality, right?
Okay, then. All right, noted. Thank you.
Good, thank you.
Thank you for that presentation. You may now stop presenting your screen.
Okay, then. All right, thank you.
Thank you. Okay, now
It's like we are done. It's like everybody has presented.
Okay, for our next presentation now, we have Ria Jose with the paper title ReefNet Deep Learning Framework for Coral Reef Health Monitoring using ResNet 152 and DenseNet 121.
Hi.
Hi. Presenter, you may start presenting now.
Thank you, Ms. Gaur. So, you can see the screen now.
Yes, we are able to see the screen.
Okay. Hi. Good afternoon, everyone. I'm Ria Jose, and I'll be presenting this paper, ReefNet Deep Learning Framework for Coral Reef Health Monitoring using ResNet 152 and DenseNet 121. Okay. And so this will be the agenda today. So as an introduction, coral reefs are one of the most diverse marine species. It supports up to 25% of all the marine. Hello?
Yes, you are audible.
Okay, thank you. It supports up to 25% of all the marine life in the oceans, and they also help to protect coastlines, and the fisheries industry and also the tourism industry is greatly affected by them. So this project, the need for this project, so due to pollution and climate change, the temperatures of the ocean are rising, and this has led to coral bleaching. So what coral bleaching is when the algae that use these coral reefs as hosts are forced to leave their reef because of these state changes. And what we are doing is we are going to classify images of corals into 3 health states, which will be bleached, healthy, and dead. So as you can see, 10% of the Western Indian Ocean corals were affected by a bleaching event in 2016 alone. And it says here like all 6% of world's coral reef is in that region. And so some other motivation is that if you were to classify these images, it needs expert knowledge, and that is not very practical. That's not very practical to be done manually. And deep learning can offer a consistent and cost-effective automatic classification. And here it also aligns with 2 Sustainable Development Goals, SDG 14 and SDG 13. And the relevance, it helps in detecting bleached corals very early, which can help these biologists restore them using some So our main objective was to develop a deep learning-based coral health classification system that categorizes these images into healthy, bleached, and dead. And so this is our literature survey. And the 2-stream deep learning for coral reef health classification was our base paper. And in that paper, they've used DenseNet 121 and ResNet 152, and also, this one, sorry, ResNet 152, EfficientNet B0, and DenseNet 121, but they were just classifying it into 2, healthy and bleached. So we've improved it by also adding another state, which is dead corals. And these were the existing solutions. And most of these were just healthy and bleached. And there is not a lot of work being done on the dead coral class. So we were not able to actually find a lot of data sets. Only a very few amount, actually it was 120 images, I think. Yes, 120 images were available for the dead corals. And this was the advantages of our work, which was that it is classifying it into 3 states. And we are also using two models, which can give a little bit more of a clearer analysis. And then yes, we have, it is very cost effective considering the alternative being human biologists having to go through these images. And then the accuracy that we've got was 96.42 for ResNet and 95 for DenseNet. So this was the work we did. And our input was a dataset called BHD corals, and it had around 1,582 images. And it was pre-processed, augmented, and then both of these models were trained on 60% of the data. And that was actually 948 images. And it was validated using 159 images. And then the images were classified into healthy dead goblins. So this was the model we used. It was the waterfall model. And we did all of these. The definition, pre-processing of the data, then training it. And then the models were implemented and the evaluation is done. These were the technologies we used. And these are the results we actually got. So for the healthy set, the ResNet 152 has a precision of 100%. But when it comes to the dead, it's gone down to 89. That was because the dead class only had very little images available. It also says that ResNet has outperformed DenseNet by a small margin, and a dead class was misclassified sometimes due to its lower amount of images being available. And so these were the advantages. And some of the limitations we faced was mainly because of the dead coral images being so fewly available. And then we only could find one dataset which had all the 3. And also, yes, the images were static. So as like future work, we would like for this to be extended to be used to classify video streams and maybe also use XAI so it becomes more trustworthy. And also be great if more data sets were available, especially for the dead class. And then multi-level classification, where they can also classify it into more conditions where it's deceased or if it has an algae overgrowth or if the sedimentation, and also an alert system. Yes, that would be very easier. It would make it very easier for the marine conservationists to do the needed action faster and more efficiently. And so this was the summary of all the work we did. And I guess it did solve a little bit of the main issue we had, which was understanding, identifying bleached coral so that it can be restored. And these are the references. Thank you. If anybody has any questions.
Thank you so much for that presentation.
Thank you.
Okay, so you have used a pretend model, a
Yes.
ResNet, DenseNet, that is the case, and whatever data set you have used, that also publicly available.
Yes.
Yeah. So whatever accuracy you get by this is a good one. But my concern is regarding, as you have mentioned in your future scope, when we go for real time inputs, right? At that
Yes.
time, whatever data is there for that pre processing will be challenging. So my question is regarding pre processing in the real time scenario, how you can modify this work.
I guess I don't think the pre-processing is needed for the test data. It was only done so that the model can understand the images better, so it can understand images in various different conditions, because mostly underwater lighting and pressure and all changes how the images are. That's why the pre-processing was done. The testing images don't need to be pre-processed. It just need to be made into the size.
Anyhow, whenever we are dealing with real time scenario, that pre-processing is required, because right now whatever data you have used, whatever images you have used, all are clean data, already pre-processed, that you have used. But when we go for
Yes, but
noisy
not.
data, yeah, at that time you may face multiple what we can say limitations, or even accuracy may get hampered. So you need to think in that direction also. Okay, thank you.
Thank you.
Thank you. Thank you so much for that presentation. And now we have Poonam Tanwar with the paper title Signature Verification Using Siamese Triplet Neural Networks with Multi Backbone Deep Feature Learning. Dear presenter, you may start presenting.
Hello, am I audible?
Yes.
Hi, this side Suryansh from Manav Rachna. I am
Okay.
presenting my PPT. Wait a minute.
Okay. You may start presenting.
Sure, sure. I think my screen is visible.
Yes, it's visible.
So my topic is signature verification using neural networks and backbone failure, deep feature machine learning. So my trainer is Ms. Poonam Tanwa, and let's start. As our topic is signature verification, so first of all I will cover that why it is matter in today's era. Like we know that in today's time we see signature verification in all the things, like to the smallest thing to the banking and check signature and all the stuff. So we can see that everyday biometrics is very important. So the main reason for that is key that biometrics should be correct. As earlier time the thing that happened is we measure the correct or non correct by the stroke of the pen and how the writer is signing. But now the things are very much different because now we sign using digital boards. So this is all about it. And now we have a problem statement. This is our problem statement. So basically our goal is to check whether the two signatures belong to the same person or not. Okay. And the biggest challenge that we got, that same person signed same signature. Like if I am signing a signature, I am the only person that's signing the signature, but sometime I sign it very fast with low very fast intensity. Sometime I sign with a different pen, different stroke. So for this we have taken our data set known as CIDAR. It is available. Okay. And for signature we use genuine and otherwise forged. Like how we can differentiate between genuine and forged. Now this is the previous work that has been done in 2017, 2020, and 2021, 2024. We can see that accuracy mentioned in the presentation 80 to 93%, less than 90%, some are having more than 90%. And most achieved accuracy is 90%, and this inspire us by making our research paper. Now I will talk about my data set. That is the most important thing. The data set is CIDAR. It has 55 writers, 24 genuine and 24 forged signature of a same writer. And the 70% of the data is for training and 30% of our data is for testing. Okay. Images are very much cleared in that data set so that we can able to train our CNN models, neural network for that. Now I will tell you about methodology that we have used. Here we have three things. First is anchor, that is the original signature. This is anchor is the original signature. Positive P is the same person's signature. Okay, and N is negative, signature from different writer, the one who is trying to copy. Okay, the model learns to keep the signature genuine and close from the forged signature so that we can differentiate. Basically we have this you are using this formula for distance. If the distance is very much small, then the signature will be genuine, and the distance will be large, then the signature is forged. Now I will tell you about my model architecture. We use ResNet 50. This is our main model. It extracts important features from our signature. Finally, and I want to convert this, that it converts every signature into different feature vectors. Like mentioned here, like dense 128, like in dense 128, it creates 128 vectors. Same for all these things, so that we can able to compress each and every minor detail from any image that we get of any signature, little to little detail. Now I will talk you about the implementation, how we implemented it. We have this image sizes that is 224 and 224. These all are the image classification that we have. We use optimizer named as Adam, and it is trained for 15 episodes. We use Python, PyTorch, and OpenCV for our implementation. And this is the we got the some result by comparing our database, that is CIDAR. We can see that mobile net v3 gives the best accuracy, that is around 79.49. ResNet 50 gives us the best ROC AUC, that is 0.887. The model has been successfully disengaged the genuine and forged signature. We can easily get the differentiation between between original and the forged signatures. Now we will provide some classification over the quantity, like precision, recall, F1, and secure, all are balanced. We can see that from the table that all of the things are quite balanced. And you can if you can able to see the graph that is on the your right hand side, the 1 and 2, it represents that 0.5 is the genuine signature of smaller distance, like it's a genuine signature, then they have very less distance. And that 1.2 is the forced signature that are having larger distance. So this is basically which helps us to identify which helps which helps model to identify that the signature is real or not, and helps us model to make the correct decision. And this is our you can say kind of benchmark as we have compared it with previous research that have been done. Previous research achieved us than 80. Previous research provide us 90% accuracy, but our model provides 80%, But there is a reason for that. The reason is that we tested on completely unseen writers, which is harder and more realistic task. Unseen writers means new entries that we are giving to our database. Now we are providing you some strengths and limitation. We, according to our thing, uh, it works cluelessly with our new users need a new signature. If we want a new signature and if we want to confirm it, is it real or not, so it works fabulously with that. And it learns features automatically without a manual prompt with it. And the limitation is the data set is small, because CDAR data set is very small. Accuracy is kind of improved. We need an improvement from our accuracy. And we here the only offline signature images are only used. And now we will move towards the conclusion. So our database model can easily verify the offline signature without any issue. We achieve 80% of the accuracy on our CDAR database. In future, we are planning to use larger database in order to get more realistic results. And that's it. Here are some of our references. If you have any question, you can ask.
So, CEDAR dataset you have used for only training purpose,
Yeah, ma'am. We have used it only for training purpose,
and for
because it's
testing, total how many signatures you have used for
and for
testing?
in CDAR database, you can see. Let me open the in CDAR database. It has 55 writers. Okay, and one writer provides 24 and 24. Like
So all
24
this
are,
data you have used for training only,
yes, ma'am. We have
and for
used total.
testing you have generated your own data.
Right.
Okay.
Basically, signature is a type of thing, na, like everybody hesitate to provide us. We have done some surveys and Google forms. So, ma'am, we have to use it. We don't have anything. We want we use some real thing, but
By our personal connections, we can try. But
we can only try because.
it's good that you have created own data for testing purpose.
Thank you, ma'am. Thank you very much. I appreciate it.
Okay. Good.
Thank you, ma'am. Have a nice
Thank you.
day.
Thank you.
Thank you for that presentation. Now we have Sneha Agarwal with the paper title AI-based multinational road damage detection and classification using YOLO V8 deep learning architecture. Dear presenter, you may start presenting.
Hello, am I audible?
Yes, you're audible.
Can you see it now?
Yeah, the screen is visible now.
Okay. Good afternoon, everyone. I am Sneha Agarwal from VIT University, and today I will be presenting a work titled AI based multinational road damage detection and assessment system using deep learning. This work presents RoadScan AI, an end to end intelligent road damage detection system based on the YOLO V8 small architecture. So let me start with why this matters. Road infrastructure is critical for safe, efficient transportation, but it's under constant stress. Traffic loads, environmental exposure, and material aging create cracks, potholes, and surface defects that directly impact safety and maintenance costs. Currently, inspection relies heavily on manual surveys, a process that's heavily time consuming, labor intensive, and inconsistent. Recent advances in deep learning and large scale annotated data sets finally make automated, accurate solutions possible. RoadScan AI leverages these capabilities for real time scalable road monitoring. Current inspection methods have four critical limitations. First, manual inspection requires extensive manpower, limiting coverage across growing road networks. Second, Human assessment introduces subjectivity, that is, different inspectors classify these damages inconsistently. Third is that infrequent inspections allow minor damage to escalate into expensive structural failures. And fourth, existing systems don't support continuous or real time monitoring. So, this table summarizes the progression of research in automated road damage detection over the years. Early approaches relied heavily on handcrafted features and traditional machine learning techniques, which showed limited robustness under varying road and lightning conditions. Following that, two-stage deep learning detectors such as faster RCNN achieved good detection accuracy but remained computationally very expensive for real-time deployment. More recent single-stage detectors, particularly the YOLO family, significantly improved the balance between accuracy and inference speed, while deployment-oriented systems demonstrated their practical applicability. So, building upon these developments, a proposed RoadScan AI integrates a YOLO V8 based detection pipeline, a control comparison with faster RCNN, comprehensive performance evaluation, and deployment as a practical road inspection system. So, our work has four core objectives. First is to build an AI system capable of detecting and classifying different road damage types. Second, minimize manual inspection dependency through consistent objective assessment. Third is to basically ensure reliable performance across varied road conditions and geographical regions. And fourth, deploy it as a production ready web application supporting single images, batch processing, and video analysis with automated PDF reporting. Now comes the system architecture. This pipeline follows seven integrated stages. Input acquisition handles single images, batches of images up to 20, or video streams. Preprocessing resizes to 640 by 640 image and normalizes the pixel values. The YOLO V8 small network performs feature extraction and detection. Then the post processing applies NMS and confidence filtering. Outputs are generated and they give annotated images, heat maps, and severity scores. Evaluation metrics measure performance, and finally, the deployment occurs via a Streamlit web application. So we trained on the CRDDC 2022, which is a large-scale multinational benchmark containing 47,000 plus annotated road images across 6 countries, which are Japan, India, Czech Republic, Norway, USA, and China. The dataset covers 4 standardized damage classes: longitudinal cracks, transverse cracks, alligator cracks, and potholes. We applied an 85 by 15 stratified split while maintaining class and country balance. Moving on to the modules overview, the complete system is organized into 5 interconnected modules that together form the proposed road damage detection pipeline. The dataset preparation module converts the CRDDC annotations from Pascal VOC format into the compatible YOLO format, retains the 4 required damage classes, and prepares the stratified training and validation datasets. Secondly, the model training module fine-tunes the YOLO V8 small model using ImageNet pre-trained weights. The training was performed for 100 epochs on an NVIDIA Tesla T4 GPU using the Adam W optimizer with cosine learning rate scheduling. The best performing checkpoint for our project was achieved at epoch 78, achieving an overall MAP of 0.572. The evaluation module measures model performance using standard detection metrics, including precision, recall, confusion matrix, and per class MAP, providing a comprehensive end to end assessment of detection accuracy. To validate our approach, A faster RCNN with a ResNet 50 FPN backbone was trained under identical experimental conditions, enabling a fair comparison between the two architectures. Finally, the trained model was deployed as RoadScan AI, supporting single image, batch, and video based road image analysis with automated severity assessment and report generation. To evaluate the effectiveness of the proposed approach, the trained model was assessed using standard object detection matrix. Starting with the confusion matrix on the left, most predictions are concentrated along the main diagonal, indicating accurate classification with minimal confusion between the four damage categories. The recall confidence curves in the center show that D20 or alligator crack maintains the highest recall across increasing confidence thresholds, while D10 or transverse crack shows the fastest decline because of its thin linear characteristics. Finally, the per class MAP comparison on the right demonstrates that YOLO V8 consistently outperforms faster RCNN model across all four damage categories. Compared with faster RCNN, it improved detection performance by 6.3 percentage points while delivering approximately 3.5 times higher CPU inference speed, making it more suitable for real-time road inspection. Overall, the proposed model achieved 90.5% precision, 88.2% recall, and an overall MAP of 0.572. So while the quantitative metrics demonstrate overall performance, this figure provides a qualitative comparison between the ground truth annotations on the left and the YOLO V8 predictions on the right. The predicted bounding boxes closely align with the annotated damage locations across multiple validation images collected from different countries. The model accurately detects and localizes the damage with only limited missed detections and very little interclass confusion. So, in conclusion, we developed an end to end YOLO V8 based road damage detection system, achieving high accuracy, which enables faster, more consistent, and scalable road assessment, shifting the maintenance from reactive to proactive. Future enhancements include transformer-based architectures for improved feature extraction, GPS-integrated spatial mapping for damage prioritization, and adversarial training for nighttime and adverse weather robustness. This work builds upon several recent studies in deep learning-based damage detection and intelligent infrastructure monitoring. That concludes my presentation. Thank you very much for your time.
Thank you so much. Do we have any questions?
Yes, Neha. You achieve or you get good accuracy over here, but what I want to suggest you, like do it one close loop, like this research part is there, but when actual prototype we develop or when we deploy it in real time scenario, then that will be definitely helpful for society also, right?
Yes, ma'am.
So think in that direction. All the best.
Thank you, ma'am.
Thank you for your presentation again. You may stop presenting now.
Hello.
Yes, sir.
I sent a message in a chat. If possible, kindly do so.
Okay, sir, it will be done.
Thank you.
Okay, now moving forward. I would like to call Sanket Lokare with the paper title of A Large Language Model for Code Generation using LoRa, a deep learning based research approach. Okay, I would like to call Badula Sivasai Harshavardhan with the paper title Heart Disease Prediction Using Stacking Ensemble Learning with Random Forest, XGBoost, and Support Vector Machine. All right. Okay. Okay, with that, we finish our presentations for today. I would sincerely thank all our authors for their excellent presentations and contributions in this session, all our participants for being a part of this international conference with their insightful presentations. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. Now, I would also like to thank our session chair so much for chairing this session. A token of appreciation to the chair on behalf of the team of ICT4SD 2026 and Global Knowledge Research Foundation and partners. Ma'am, it would be really nice if you could share some words with us today to end the session.
Yeah, sure. Thank you so much for providing me such opportunity. All presentations are really good. So thank you all the best.
Now, I would just request everyone to switch on their cameras for a quick snapshot of the virtual discussion. Thank you so much. Stay safe and take care.
Thank you.